Hello, young scientists. Welcome back to our Science Investigatory Project lesson series. Today, we're diving into one of the most important chapters of your SIP, Chapter 3, Methodology. At the end of the lesson, pupils will be able to 1. Identify the components of the methodology section, subject of the study, procedure, research design, and statistical treatment. 2. Explain the purpose of each component with examples. 3. Create a simple methodology outline for a given SIP topic. Priming activity. Imagine you're a scientist who wants to find out which soil type is best for growing plants. What would you do first? What would you need? How would you test it? Group tasks. 1. The class will divide into 4 to 5 groups. Each group has assigned specific SIP topic. Example: how does sunlight affect plant growth? 2. You will ask to think about what or who you would study, how you would do it, and how you might record or analyze your results. You can refer to the provided example here on how you will do the activity or tasks given to you. Here are the specific assigned tasks for each group. Components of methodology. Your methodology is the roadmap that leads you from your research question to your final results. It's where you outline everything: how you'll gather your data, what materials you'll use, and how you'll carry out your experiment. Let's break down the 4 key components of a good methodology. Subject of the study. This means what or who is being studied in the investigation. Example: if the topic is how does sunlight affect plant growth, the subject of the study is 3 bean plants. Procedure. This means it is a step-by-step instructions for conducting the experiment. Example: 1. Place 1 plant in full sunlight, 1 in partial sunlight, and 1 in the dark. 2. Water the plants equally every day. 3. Measure their growth weekly for 3 weeks. Research design. It is the overall plan of the experiment, including how the variables will be tested and whether there's a control group. Example: variable: amount of sunlight, full, partial, none. Control group: the plant in normal sunlight serves as the control to compare against other conditions. Under the research design, include the theoretical framework. The theoretical framework is based on principles or theories that explain how the independent variable, sunlight, affects the dependent variable, plant growth. You can show or illustrate your theoretical framework based on your study like this. You can read the example of how you will write your theoretical framework based on your study. You need also to include the conceptual framework in your research design. Conceptual framework visually represents the relationship between variables and how the experiment will be conducted. It must include the input, process, and the output of your study. You can read the example of how you will write your conceptual framework. Another component of methodology is statistical treatment. This is how data will be analyzed to make sense of the results. Example: pupils can measure the height of each plant every week and calculate the average height for each condition to see which grows best. To analyze the results, you can make a graph or table just like in the example presented. Or you can do your statistical treatment like this. Why its components of methodology matters. 1. Subject of the study. Helps identify what is being tested. This is the heart of your experiment because it tells us what exactly you're testing. For example, if you're testing how different amounts of water affect plant growth, your subject is the growth of plants. The subject gives the research its focus, so knowing what you are studying is crucial. 2. Procedures. Ensures others can replicate the study. Think of this as the recipe for your experiment. It's a detailed step-by-step guide on how you did your research. Why is this important? Because it ensures that others can repeat your study and get similar results. Without a clear procedure, no one can verify your findings or test your hypothesis on their own. 3. Research design. Provides a clear way to test variables. The research design provides a structure to your experiment. It helps you decide how to test your variables. Those are the factors you're changing or measuring. A good design makes sure you test your ideas in a way that gives you reliable and meaningful results. Without a clear research design, your experiment might not show what you intend to find out. 4. Statistical treatment. Helps understand results through analysis. This is the way you analyze your data. It's the method used to understand and interpret the results of your experiment. By using statistical treatment, you can see if your findings are significant or just a result of random chance. Without this, you wouldn't be able to draw meaningful conclusions from your data. Each of these components plays an important role in making sure your science investigatory project is well done, reliable, and meaningful. Remember, the subject of the study defines what you're testing, the procedure allows others to replicate your experiment, the research design gives you a clear way to test your ideas, and the statistical treatment helps you analyze the results. Together, these parts make your research strong and trustworthy. Let's check your understanding of the components of the methodology in a science investigatory project. Are you ready? 1. What are the 4 components of the methodology? 2. Why is it important to have a procedure in your SIP? So, now that you understand why each component matters, let's get started on planning your own SIPs. I'm excited to see your ideas and experiments come to life. Write the methodology section for your chosen SIP topic, ensuring all 4 components are included. You can copy and click the link below to access an example of the complete write-up for your Chapter 3 SIP methodology. Remember, a well-structured methodology is the foundation of any successful science investigatory project. With a clear subject, precise procedure, thoughtful research design, and careful statistical analysis, your experiment can stand strong, and your discoveries can make an impact. Keep experimenting, keep learning. Thank you. Until next time.